status panel is a very important part of the mission, both especially before the mission. They are a real-time summary of everything that it takes to prepare, to launch, and to follow Ariane. You can see in the upper left of the screen there, it's behind us here in the hall on the far wall, the green status panels. We like to check them. There they are on the right from time to time before lifting off. And you see the color is green, which is just as it should be, so all is well. What they are is a go, no-go, red-green summary of everything that it takes for a mission, an Ariane or a Soyuz or a Vega, for that matter. Green means okay, red means the opposite. It's very simple. If you see a red in any of those, it means that we're going to stop the countdown. The space base covers a lot of area and information from all these services, and you can see them there. They're safety and telemetry and the weather and the satellites and all that information coming in here to Jupiter from the different outposts, which is why we call Jupiter the nerve center and the real heart of the space base. Back inside of Jupiter, we're going to take a look at some other key players. We're going to look at the satellite mission directors, also called the DMS. These are people responsible for the chronology of their satellites. They decide if their satellite is ready for launch. They follow the campaign step by step and its preparation as managers. They meet with their teams on a daily basis, of course, and give the okay for each stage of the satellite's preparation. Most of them, I would say, are technically oriented, and every Ariane Space customer will have one. You should be seeing Véronique Loisel of Ariane Space coming up, and you'll be hearing from her later on in another film. And all these players we've been mentioned are an important part of the launch base. And, by the way, what is a launch base? Well, it's a place where the launcher and the payloads are prepared. They are launched and monitored before and during the mission. This one, the CSG, happens to be the world's only dedicated commercial space base, Ariane Space operating the launcher family. Total mission time, as we mentioned, 26 minutes. Not exactly standard for an Ariane Space launch. Usually it's a little longer, 45 minutes or an hour, depending on the mission. Two other people you're going to be seeing today from Ariane Space: the mission director, Didier Saïd, working alongside the range operations manager, also called the DDO, tonight, Raymond Boyce. And it's his voice you're going to be hearing in just a moment, when he's going to be calling out the 7-minute mark. That's an important milestone. We'll explain that in a moment. This person, the DDO, makes all the key announcement on the major milestones during the countdown and during the flight. And he will shortly call out the 7-minute mark, which is a key milestone. We're into the final moments of the final countdown as we wait for the DDO to call out the final
À tour de DDO, attention pour la séquence finale lanceur.
That's the DDO coming down to the 7-minute mark, and you'll hear him again.
Top à 0-7 minutes.
All right, there we are. 7-minute mark brings us into what's known as the synchronized or the automatic sequence. It's a key milestone representing really the tip of the iceberg, the final moments of final countdown. A complex series of operations running right down to liftoff, making the launcher autonomous. Our stage is set. I'm going to go up to the broadcast booth. While I'm doing that, take a look at a film on the launcher campaign to see how Ariane is put together for the mission.
The VA-245 launch campaign started in the integration building, the BIL, on September 6. After the stages assembly and the fluidic and electronical functional checks, the launcher was transferred to the final assembly building, the BAF, 2 weeks ago. The nominal planning has been adapted to take into account all the specificities of this single launch.
BepiColombo is also a totally atypical launch campaign carried out over 6 months at the Guyana Space Center. First of all, 4 Antonov aircraft brought the spacecraft's elements and equipment to French Guiana. In addition to these Antonovs, about 10 more containers arrived by boat. During the spacecraft preparation phase at the S5C payload preparation complex, BepiColombo occupied the 2 clean rooms configured as one large room. The spacecraft teams proceeded step by step to unload and install the spacecraft modules in the clean room, to integrate the components onto these modules, to carry out electrical tests on different modules, to meticulously install thermal insulation, which is carefully tuned by hand, to check the different onboard propulsion systems of the modules. Solar panels were fitted onto each module of the spacecraft. We're all impressed by the solar panel deployment test carried out across the huge structure built in the room. The filling of BepiColombo's different modules was carried out in between all these operations according to well-established schedule. The MMO, the Japanese Space Agency's module, was integrated onto the European Space Agency's module, the MPO. Then the assembled modules were installed on the MTM, the transfer vehicle. After its preparation phase, BepiColombo was transferred to the final assembly building to be integrated onto the launcher. Once onto the launcher, the finishing touches were carried out and the MOSIF sun shield was integrated onto the spacecraft. The launch round rehearsal took place on October 15th, and the launch readiness review authorized the transfer of the launcher and its spacecraft to the launch zone on D1.
The final operations are now ongoing. Cryogenic fillings started 4 hours before the launch. Flight software has been uploaded into the onboard computers, and the synchronized sequence will be started around 7 minutes before liftoff.
Joshua Jempel back up in the broadcast booth with Johannes Benkoff of ESA, ESA's BepiColombo project scientist. Wonderful title. What's the job about?
Oh, hello and Ohio gozaimasu, Japan. Yeah, being project scientist of such a mission with 2 spacecraft and the collaboration between Europe and Japan is such a fascinating job, because you have dealing with all aspects of science, and you are the interface of the scientist, you deal with the engineers, you steer the science operation, so it's a great job.
Terrific. We'll hear more on that in a moment. But for now, we want to take the cameras up to the Launch Campaign Operations Center, where the teams are working, several teams up there, under the direction of this fellow, Rafael Breda, who's the Launch Complex Operations Manager. Several teams up there, as we said. One is responsible for the ground operations, the other for readiness of the Ariane 5. The Launch Campaign Operations Manager heads up one group, and he coordinates with Mission Control for final authorization to launch, and when all the conditions are right, he then okays the automatic sequence at the 7-minute mark, which we just saw, in all about 100 people up there. How long have you been on the project?
Oh, I've been on the project for 15 years now, and for more than 10 years I'm the project scientist. And as I said, I'm the voice of the scientist, and that's a very complex thing, because on BepiColombo we have 16 instruments on both spacecraft,
yeah.
And all in all more than 30 sensors. And so not only technology-wise, also from the science, it's a very complex mission.
Okay, we're going to hear more from you when you come back, because Johannes has never seen a launch. Excuse me, he's going to go out on the terrace with all the other VIPs and give us his reactions, hot reaction, when he comes back. So don't get lost. See you later. The split screen image on the screen on the left, liquid hydrogen, on the right, liquid oxygen. These are the propellant feeder arms in the middle of the launcher. We'll get another shot of that when we pull back. They are putting fuel into the upper stage tanks, and you'll see the arms, and you can see them there in the center of the screen, coming out of the gantry into the upper stage. You'll see the arms pull back at 7 seconds before ignition. What are the people doing? They're going out onto the terrace there, because we have 2 terraces on either side of Jupiter that give a wonderful view onto the launch pad, which is about 15 kilometers away from us here, and that's where Johannes is gone. The DDO is going to call out.
Top, I0 1 minute.
And there we are. We're into the final 60 seconds as the crowd gathering on the terraces. Give us a chance to say hello to our friends at JAXA Tokyo, Airbus in Friedrichshafen, to our industrial partners, ESA, including ESOC, where we'll go momentarily, and CNES, and to all of you following the broadcast on the internet. We hope you are enjoying it. We're going to cut away now and let you listen to the DDO as he calls out the final countdown. Watch for the cryogenic arms to open and enjoy the liftoff.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage 2EAP, décollage. Propulsion est nominale, la trajectoire est nominale.
Roar of her engines, a lot of fire, and with BepiColombo on board, the DDO says all is well. The two boosters now providing 90, that's 90% of our thrust, propelling the launcher along her trajectory at an ever higher velocity. 780 tons at liftoff, that's the mass. And to get that sort of mass off the ground, you need a lot of push. And push we have. She's burning 5 tons of fuel every second. 2.5 tons being burned every second in each booster, plus the core stage burning another 300 kilos of fuel every second. Ariane 5 putting on quite a show. And I can't wait for Johannes to come back and tell us his reactions. The sky is clear. You should be able to see separation of the boosters, maybe even separation of the fairing. We'll find out momentarily. Ariane 5 now following the program and the onboard computer, which gives all the orders, including stage separation. We'll soon see that in just about 30 seconds from now. We are in the first of 4 flight phases. The first 3 are powered, and we'll describe each in turn so you can follow. Right now, the first flight phase, the single first stage engine, and the 2 boosters are burning. The boosters will each consume their 240 tons in just over 2 minutes, and in just about 10 seconds. They will be the first to be extinguished, and you'll hear that from the DDO, but you'll see that on the screen. You'll see the flame out there.
Pilotage calme, trajectoire nominale.
There it is. You see the main point of light in the middle. When we come back to that, and 2 points of light on either side are the boosters. That's what it looks like up there. There's another booster on the port side, of course, out of camera range. But you see the main point of light looks like the moon in the middle, and on the side the 2 boosters flaming out, and they will fall into the Atlantic. French Guiana, in part chosen as a base for its opening on the ocean, launches posing no threat to the local population, of course. We're waiting for Johannes to come back. Before he comes back, our next milestone, separation of the fairing. That's next up as we continue to follow Ariane with looks like a ground camera or the naked eye.
Séparation de la
the launcher making her way. The DDO has called out separation of the fairing, and this is what that looks like. There's another half on the starboard side, which is falling into the Atlantic as well. We can separate the fairing now. Why? Because we're out of the dense layers of the atmosphere, of course. Over 100 meters altitude, and you can see on the bottom of your screen on the left our altitude 140 kilometers, and on the right our speed 2.4 kilometers per second. We can also discard any dead weight. The fairing excuse me, weighs 2.5 tons, so it's a good idea to get rid of it now that we can. The guests coming in after being treated to a wonderful sound and light show. On the left there is the satellite, the white boxes. Below that is the composite. One reason Kourou was chosen as the launch site was its nearby hills, where we could install radar and telemetry facilities, and that's where we're going now. This office, another place that is very active tonight, the CVI, or the Quick Look Telemetry Display Control Center. Now these teams have all the means for receiving, processing, storing, and analyzing all the data coming in from the ground stations. We'll have more on that along Ariane's flight path. The CVI station at top of hill, and you just saw, not far from Jupiter, And right now, these teams are following and analyzing all the key flight data coming in and reporting the flight status of the launcher back to the teams here in Mission Control. It's all part of the great information flow from points across the base to Mission Control, Jupiter, the Nerve Center. And Johannes has returned, and you are smiling. Tell us, how was it out there?
Oh, it was fantastic. I've never seen that before, and it was great.
Yeah, what impressed you the most? Was it the sound? Was it the light? Something else?
Oh, it was the brightness of the rocket when it went to the sky, and yeah, you could not see the rocket. It was like a big fireball going up to the sky, and it was really amazing.
Super. Did you see the separation of the boosters?
Yes, you could see it.
Nominal.
Great. Okay, so if that doesn't make you want to come down here and watch a launch, ladies and gentlemen, I don't know what will. Next up, we want to find out...
Il reste 3 minutes de propulsion de l'EPC.
I imagine, like most missions, you had some problems. We're going to have to go to a film, but give us a first taste, and we'll continue after the film. Any problem that you solved that you remember?
Oh, BepiColombo was a bumpy ride from the beginning. We had issues with the solar panels, which were not standing the combination of heat and solar radiation, and for that reason we had to make them much.
You might remember some of those flights. Maybe you were even here in Jupiter for the launch, like Johannes was. We were just picked up by our first downrange tracking station. We promised some information on those. It's located in Natal, over the border in our neighbor Brazil, run by the Brazilian Department of Defense for CNES in an agreement with ESA. Now, we are building, BepiColombo is going to build on some of the science that was discovered by Messenger, the NASA project. How so?
Yeah, before the NASA project Messenger, we did not know much about Mercury. We only had data from flybys in the 70s, and also there we could only see 1/2 of the planet. And even people, when they heard about BepiColombo, found it's a boring target. But all that has changed after Messenger, because we found out that Mercury is a fascinating, surprising planet with a lot of mysteries, which some things which we have never expected before. For example, formation temperatures were measured, which are much lower than expected. You would expect for a planet close to the sun, the temperatures are much higher, but actually we found they were much lower, comparable to formation temperatures of Mars. So there could be the idea that Mercury is formed somewhere else, so that would be fascinating.
What argument did they use to say that it's a boring target?
Oh, in the beginning they said
that sounds...
They had no atmosphere, only a few craters. They didn't expect life on Mercury, and for that reason, maybe it was boring.
Okay, we have had cutoff of the lower stage engine and separation of the lower stage engine, and as you can see on the animation, ignition of the upper stage, all on time. These are 3 commands given by the onboard computer in about 13 seconds. So we are now into the final powered flight phase. It's the single upper stage engine that will burn until plus 2510, or another 16 minutes roughly. The job of the upper stage, taking the satellite to its injection point, positioning it for separation, and then releasing it. That's its propulsion role. But she also has a second role, and that comes during Ariane 5's what they call ballistics phase. Our next film from ESA, an overview on the BepiColombo mission.
Fueled and almost ready to go, the final assembly of the BepiColombo mission to Mercury. A collaboration between ESA and the Japanese space agency JAXA, BepiColombo consists of 2 scientific orbiters, a transfer module to propel them to Mercury, and a sun shield. Protected by hand-stitched ceramic thermal blankets, the entire spacecraft is 6.5 metres high and will only just fit inside the fairing of its Ariane 5 launcher. Designed to withstand temperatures of up to 450 degrees Celsius, BepiColombo is one of the most technically and scientifically complex missions ever launched.
80% of our material needs to re-qualify for this mission because we hadn't tested before in that harsh environment. So it's a real challenge to go there and to bring 2 spacecraft in an orbit around Mercury.
The first challenge is getting to Mercury. Flying directly isn't an option. The sun's gravity means any spacecraft would be going too fast to make it into orbit. Instead, BepiColombo will take 7 years to reach its destination, combining solar electric propulsion with a total of 9 flybys of Earth, Venus and Mercury.
When we fly, we constantly brake against the sun because we fly into the inner side of our solar system. Yeah, and when you fly towards the most heaviest element there, you constantly accelerate. We don't want that. This is why we decelerate.
Once they arrive at Mercury in late 2025, the orbiters will separate from the transfer module to begin their comprehensive scientific mission in 2026. With its 11 instruments, ESA's Mercury Planetary Orbiter will study the surface and internal composition of the planet. Meanwhile, JAXA's Mercury Magnetospheric Orbiter's 5 instruments will study the planet's magnetic field. Together, the orbiters will not only reveal more about Mercury, but also the history of the inner solar system.
Because Mercury is not tilted like Earth, it's spinning almost in the orbital plane. Therefore, there are some craters on the poles which never see sunlight. And in these craters, we found water ice. And this water ice could be stable over millions and billions of years. And that's a fantastic thing also about Mercury.
ESA science and engineering teams have been working on BepiColombo for more than a decade. With a long journey ahead of it, the launch marks only the beginning of the next stage of BepiColombo's voyage of discovery.
I'm taking Terry's place for the moment out here on the terrace because I want to introduce to you Johannes Penkoff. You heard his voice, but you haven't seen him. So if we get the camera on him or the drone, well, there we are. I have a question for you, and I may have to cut you off because we're going to go to ESA. But briefly, mission life, BepiColombo, 8 years. Why 8 years?
Yeah, it takes us a while to go there. We need 7 years to go to Mercury, and then it's 1 year of nominal mission. We hope that we maybe can get an extension of 1 year because the spacecraft is also designed to last 2 years in an orbit around Mercury.
How do we get an extension?
Oh, you need to make a proposal with our agency, but if everything is good, then I think I'm quite confident that we will get this.
Okay, let's get the word from ESA. We'll go to Darmstadt. We're going to speak with Paolo Ferri, head of operations there. Paolo, can you hear us? We're coming to you live from Kourou.
Yes, I can hear you very well.
Great, okay. We want to ask you a few questions. We don't have a lot of time. But first I want to ask you, what's the mood at ESA? How would you describe it up there?
Well, everybody here is very tense, waiting for the signal to arrive. As you know, we lost the telemetry at the moment of liftoff, so we're not in contact with the spacecraft. And our job will start after the separation of the spacecraft from the rocket. So we are really looking forward to that moment.
So the mood from liftoff was what? Concentrated, focused. I don't want to say tense.
Yes. Yes, certainly tense, but everybody excited. We've been preparing for this mission for so many years. We were really looking forward to this moment. Now it's the time to go.
Okay, this moment is this moment. What happens next, both in the short term and in the longer term?
Yeah, in the short term, after we have acquired the first signal in a few minutes from now, We will have the team working here for about 2 to 3 days, getting the spacecraft ready for its long cruise to Mercury. There will be some activities like deploying antennae for the communications when the distance increases from Earth, and of course checking that all the systems are ready. Then there will be a more, let's say, a longer phase of a few months where we test the onboard systems, the payload instruments, and very important
Paolo,
will be
I'm going to have to cut you off. I'm terribly sorry. We have to go to a film, but Paolo Ferri, many thanks.
Okay, very good.
East. She will shortly be picked up by our downrange tracking station in Libreville in Africa. You're watching Ariane Spaceflight 245. On the extreme right is BepiColombo. Now, what are we looking at? That's the sun shield on the extreme right?
Right, we see the sun shield, and behind the sun shield, the Japanese spacecraft is hidden.
All right, we'll be back with more. We're going to go to the film on JAXA and its role on the mission.
Konnichiwa. I'm Gon Murakami, project scientist of BepiColombo in JAXA. Mercury is one of the most mysterious planets in the solar system because it is very hard to explore, and in the past, only 2 spacecraft reached there. But we think Mercury has the key information to answer the questions about planetary formation, evolution, and its environment. So BepiColombo will explore Mercury and address such questions with 2 spacecraft and with various types of instruments. And our spacecraft, MEO, will focus on studying Mercury's environment because Mercury is exposed to the strongest solar wind in the solar system, and we want to understand the solar wind effect on planetary environment. We still need to wait 7 years for science data from Mercury, but I'm very excited for at the launch. And I want to say arigato to all members.
Hello, I'm Hiroyuki Ogawa, thermal engineer of MEO. I'm working on the Mercury mission for 20 years from the beginning of the BepiColombo project. The BepiColombo mission is very challenging from the thermal point of view. There have been many problems we have never experienced before. There is coming from the high temperature. We had to do many activities to solve them. The development was very, very tough. But now we are ready to launch. I'd like to say to everyone who has supported us, thank you very much for everything you did. Go BepiColombo, go Mio. BepiColombo is an international collaboration between ESA and JAXA. When we start the collaboration, since we do not know each other, background and also the personality, and that caused many troubles. But after a few years, we know each other, our personality and their personality, and also the background. And then we can find the solution when we meet the problem. And now we are at the launch site, and just before the launch. I believe BepiColombo is a very good team. And the relation between ESA and JAXA is very good. And the relation between also the companies relating the BepiColombo is also very good. And we still have 10 years for the end of the mission, but I believe this good relation continues until the end of the mission. And also I believe BepiColombo is a model for the following mission between collaboration between JAXA and ESA. Thank you.
3 minutes to go in the upper stage burn. Let's talk about the physics, Johannes, the flybys, the gravity assist. They bring BepiColombo, we heard this morning, into the inner solar system, and we need 6 flybys around Mercury to get into its orbit. Is that right?
Yeah, that's right. You need, unfortunately, a lot of energy to go into the inner solar system because you have to brake against the sun. And you need either pump a lot of fuel to go there, but since we have a very heavy spacecraft, for us the enabling technology is also use the help of the planets to gain some energy by flying by of the planet. And on the way to Mercury, we need to have 1 flyby at Earth, 2 flyby at Venus, and 6 flybys at Mercury.
In our next film, a look at the relationship between Ariane Space and BepiColombo.
Uli, I know the involvement of ESA, JAXA and industries was considerable during all of those years of development and AIT, including during this 6-month launch campaign. Would you say the relationship between entities was a strength?
BEPI is a very international project with contributions of a large number of European countries, the United States, Russia and of course Japan. As such, the teams running the development, procurement and also the launch campaign are of a very mixed nature. Working together was for us a very normal business over the years, independent from the individual's nationality. Due to the common objective to bring a reliably working spacecraft into orbit, the team spirit was one of the driving elements to work successfully over such a long period as we have done for our project.
Could you explain in a few words what will happen from separation from launch vehicle up to Mercury descent?
BEPI will separate approximately 28 minutes after launch, performs the deployment of the solar arrays, the antennas and the magnetometer boom, and then, after a small commissioning period, starts its 7 years long journey to Mercury, where we will arrive in December 2025. To reach Mercury, we need the energy from 9 planetary flyby assists, 1 time Earth, 2 times Venus and 6 times Mercury itself, before entering the Mercury orbit. Arriving there, we will jettison the MTM first, then the spinning JAXA orbiter and the structure MOSIF, which protected the MMO during cruise, before we will lower the MPO into its lower orbit by chemical propulsion.
And once BepiColombo reaches Mercury in late 2025, the orbiters, as you saw, will be released and captured by the planet's orbit. The science doesn't begin immediately, though. We'll get Johannes to explain that in a moment. Science begins about 5 or 6 months after that. We're coming up on extinction of the upper stage, and you will see on the left the nozzle will shut down. And we will be into the, there you are, And we are now in the final flight phase, the non-powered flight phase. We are coasting. With the upper stage engine shut off, we'd entered this coasting phase. Usually during this period, the composite is maneuvered and spun up in a series of operations ranging from a few seconds to a few minutes. This is to separate the first satellite and the Silda, which is the carrying structure for our second satellite, and then the second satellite in different altitudes and different positions. But we don't have a second passenger, of course, tonight. And we have just over 1 minute between extinction, which we just saw, and separation of BepiColombo. So the ballistics phase is very short. Now, we have about 3 minutes to go until separation. So a quick question. Mariner 10 discovered that Mercury, like Earth, has a magnetic field. The only other planet to have one. We don't know why.
That's correct. We don't know why, and it was a great surprise when it was discovered in 1974, because for such a small planet, nobody assumed that it could have a molten outer core, because you thought the planet is totally solidified. And that is what we would like to understand, how this magnetic field is formed, what is the effect of the sun on the magnetic field. And for that reason, we also have two orbiters which can distinguish between inner and outer fields. And we have a magnetometer on our spacecraft, the MPO, and one magnetometer on the Japanese spacecraft, MIO.
Your baby is scheduled to be separated in, I would say, half a minute. What's going through your mind now?
Yeah, I'm still not relieved.
You're going to be waiting for what you want to see, that everything happens. Right?
That's correct. I would like to see the separation going well, and then also the deployments afterwards.
And then we have to wait for confirmation, and we'll get back to that. But it is a moment of high concentration as we wait the DDO's announcement. The mood here in Jupiter, like the mood in Isak, as Paolo Ferri told us, very concentrated, very focused.
Séparation BepiColombo.
There is separation. The DDO has called it out right away, and you can hear the applause. So there's the good news, at least on the scheduled program of events. However, we have to wait for confirmation. Can we get a reaction from you?